Hello, this is today we are going to be covering representing functions as graphs. So now we're going to be using graph paper and we're going to graph them. And so we're just going to review some definitions to make sure that you know them. Okay, you can use graph to represent a function. And in a given table, each corresponding pair of input and output values form an ordered pair. That's our XY coordinates. Okay. An ordered pair of numbers can be plotted as a point. So this ordered pair is a point on the graph. The X coordinate is the input. The Y coordinate is the output. The horizontal axis of the graph is labeled with the x-axis. And the vertical axis is labeled with the y-axis. And I think most of you, this is a complete review. So, here we have a function. The function is y equals x plus 1. And we are given the domain. And the domain is 1, 2, 3, 4, and 5. So we create our XY table and we plug in the numbers 1, 2, 3, 4, and 5 into the table. And then we look at this function and we say, okay, I'm going to calculate my y values. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. 5 plus 1 is 6. Easy peasy. Then we graph it. All right? And make sure that when you do your graphs, okay, you label it X and Y. And another point is that you don't have to label every single number, okay? You could do it so that it's clear to whoever's reading this that this is at 5. So you don't have to write the 1, 2, 3, 4. And over here, this is at 5. So you don't have to take the time to write every single one of those numbers. So the question is, we plotted those points. Okay. Now this is up for debate. We're in Algebra 1. If we were in Algebra 2, this would be really important. All right? We are given specific numbers here. 1, 2, 3, 4, and 5. Since we are given those specific values in the domain, we should only plot these specific points. Now, if you draw the line, I'm not going to mark it off. I just wanted you to be aware that we were given exact numbers, we have exact points, and when you get to Algebra 2, you wouldn't draw the line, but here most of us are going to draw the line. All right. So now, we're going to do this problem together. Write a function rule for a graph. Right? Write a function rule for the function represented by the graph. Identify the domain and range of the function. So the first thing I would do is I would take these points and put them into a table. So we have the ordered pair 2, 0, 4, 1, 6, 2, 8, 3, and 10, 4. And we want to look for a pattern. Okay? Because remember, the rule is going to be y something. Right? So you can see, and I start with 0. Right? And you don't have to show this work, but mentally, right? If you wanted to get to 0, okay, well, you could subtract 2. But if I take 4 minus 2, that's not going to work. And 6 minus 2, that's not going to work. Okay? So if I'm thinking about this, how do I get to 0? And I'll say to myself, okay, I'm going to take 2, and I'm going to multiply it by something, and I want it to be 0. So if I take half of 2, that gives me 1. And 1 minus 1 gives me 0. And then let's see if it works for 4. If I take 1/2, okay, of 4, that's going to be 2, minus 1 is 1. So it's checking. And then I would go down to 10. Let's take 1/2 of 10, okay, minus 1. So 5 minus 1 is 4. And so we're looking at the pattern. And so we now can write our function rule, 1/2 of x minus 1. And that is the rule. Now, some of you might remember that for a line, the equation's y equals mx plus b. Right? And if you remember rise over run, okay, this is going to rise 1, run 2. So that's a half. And then we know the y-intercept has, if we drew this line, the y-intercept has to be a negative number. That can give you some clues as to how to write these rules. So now it says the domain of the function is x equals, and it's these numbers right here, 2, 4, 6, 8, and 10. And the range is these numbers here, y equals 0, 1, 2, 3, and 4. All right. So we're going to do another example. Actually, I think you can do this page yourselves. So I want you to pause the video and see if you can do this page yourselves. Okay, going back to the first example. So this is the first example that we did. So you're going to follow this methodology to do this problem. And then you're going to follow this methodology to do these two problems, the next two problems. Okay, so pause the video, see how you do. Well, I bet you had no problems doing the first example. Okay, our function is y equals 1/3 x plus 1. Our domain, we create our xy table. Do not forget this table. You could do the table like this. Okay, but you have to label the table x and y. So you're going to put in your domain. Then you're going to take these numbers, plug them into this equation to find your y values. So 1/3 of 0 is 0 plus 1. And then 1/3 of 12 is 4 plus 1. And I'm sure you got that perfectly correct. All right. So now the range is the y values. So that was easy peasy. So now, how many of you got the rule y equals 3x minus 3? Right? So first thing I told you is take these points, and create a table. So here's my table. And as you can see, if I draw this line, I've got a couple of things that help me out. I know that this number has to be a negative number. Okay? So this is going to be a negative number. And I can see that my graph is steep. So that means that my number is going to be larger. So here is the equation. And you can double check it. And this over here, you don't have to show that work. Okay, so if I take, for example, x is 1, 3 times 1, 3 minus 3 gives me my 0. And then if I try the 4, 3 times 4 is 12, minus 3 is 9, so it checks. And then it asks you for the domain and range, which is simply here's the domain, here's the range. Next problem, did you get y equals 1/2 x plus 5? Okay. Now remember I told you kind of like the pattern here. We know that better be a positive number. And guess what? It's a number between 4 and 5. And this line right here is not as steep, so that's why we have a fraction. So if I take number 2, 1/2 of 2 is 1, plus 5 is 6. All right. So that's it, and have a good day.